Okay, so we're going to title our notes today, Demoivre's Theorem and Graphing Polar Coordinates. So first of all, let's talk about what Demoivre's Theorem is. So if we have something raised to a power, so something to the nth power, I'm just going to use n. Basically what Demoivre's Theorem says is we take the radius and we raise it to that nth power. And we take the cosine of theta in trig form and we multiply it times basically the power plus I sine theta times the power. So I'm going to, for our first example, I'm going to give you one in trig form here. So let's say that they tell us that z is 12 cosine 20 plus I sine 20. And we want to do z to the third power. So basically all we're going to do is, since we're raising it to the third power, we're going to take the radius to the third power, so the radius is 12. We're going to take cosine of 20 times the power, which is 3, plus I sine 20 times the power, which is 3. And that's really all Demoivre's theorem says. It's just our power rule to be able to multiply when we have a power, really 2 or bigger. So now it's just a simplification process. We do 12 to the third power in our calculator. We know 12 to the third power is 1728. The cosine of 20 times 3, well, that's the cosine of 60, plus I sine 60. Now we know from our unit circle the cosine of 60 is just going to be 1/2. That's one of our special angles. We know that the sine of 60 is going to be radical 3/2. And now we just distribute the 1728. So 1728 times 1/2, or divided by 2, however you want to word that. It's going to give us 864. And then 8 plus 864 radical 3 I. And we're back to complex form. So for example 2, let's say we have -1 plus radical 3 I raised to the 12th power. Now what I'm going to suggest is, just like we've done in previous problems, so we can use Demoivre's theorem, we're going to go ahead and put it in trig form first. So we're going to go through that process of what we just did on our warm-up. We're going to graph it, which when we graph this, -1, and we're going to go up radical 3, and draw in our triangle. So -1, radical 3. If you remember your ratios, 1 radical 3, 2. What kind of triangle is this? This is a 30, 60, 90. So if you know your ratio there, R is going to be 2. If you don't know your ratio, you can again do, radical 3 squared plus 1 squared. You're still going to get 2 for your R value. Okay, so we know that R is 2. Because we know it's a 30, 60, 90, we know that the alpha here is going to be 60 degrees, which is going to make theta what? If this angle here is 60, then we know that theta is going to be 120 degrees. And now we can write our trig form. We know it's 2 cosine 120 plus I sine 120 Now remember what we're doing here. We're doing this to the 12th power. So you think about it, to the 12th power. Demoivre's theorem says we're going to take the radius to the power, so 2 to the 12th. We've got cosine of 120 times 12 plus I sine 120 times 12. Again, let's go ahead and put in 2 to the 12th into our calculator. Everybody agreed 2 to the 12th is 4,096. And we're doing cosine 120 times 12 is 1440 plus I sine of 1440. Now, what are we going to do with 1440? Well, we got to kind of start thinking about, where does that fall? So I would start, can we divide 1440 by 360? What's that give us when we divide it by 360? Doesn't it give us 4 evenly? Yeah. So basically that means we're going around the graph 4 times. So I'm going, there's 360, there's 720, there's another 360, and then there's 1440. So I'm ending, basically I can think of this as being the cosine of 0 or the cosine of 360. Does that make sense? So think about it in those terms, cosine of 0 plus I sine of 0. Well, what is the cosine of 0? Now we plot the point here at 0. The x value is going to be 1, right? So 4,096, that's 1. The sine of 0 is 0. So 0 times I, that's just 0. So 4,096 times 1 is 4,096. And that's our answer for that one.
What are you doing with that number?
What are we doing with that number?
Yeah.
Well, that's just simply going to be our answer. That's what -1 plus radical 3i to the 12th power. That's the value of it.
Okay.
Example 3, I want you to try this one. So -1 minus I raised to the 4th power. So I want you to go ahead and try that one. And we'll come back together in a few minutes. So again, the first thing we'd want to do on this, we want to go ahead and make our graph to find our R value. So we're plotting the point -1, -1. So we've got -1, -1. We know this is because it's a 1, 1, it's going to be, what's the radius going to be? Radical 2. That tells us this is a 45, 45. So we're going to do 180 plus 45 for theta. So hopefully you got 225 degrees for theta. Now, guys, something else I'm going to just kind of do on this one, and again, you can do this however it works best for you, but if I were putting 225 into radian form, what would that be? So we know it's pi all the way to 180, right? Then we're going to add another pi fourths. So everybody, hopefully you agree that that would be 5 pi fourths for theta. Now, I'm going to put it in that form, and again, if it's easier for you to leave it in 225, you can do that, but just so you can see here in just a minute why I'm doing that. So the radius is radical 2. We've got the cosine of 5 pi fourths, or 225, plus I sine of 5 pi fourths. Now we're taking that whole thing and we're raising it to the fourth power because of our original problem here. So we get radical 2 to the fourth power, the cosine of 5 pi fourths times 4, plus I sine 5 pi fourths times 4. Now we go to our simplification, radical 2 to the fourth power. It's like saying it's going to become radical 16, which is just 4. Now think about here, we multiply 5 pi fourths times 4. That's basically saying the cosine of 5 pi plus I sine of 5 pi. If we'd left it in degrees, it's cosine of 900, sine of 900, I sine of 900. That would be 225 times 4. I think sometimes you think of it in terms of pi, think about where that is on the graph. Basically, 5 pi is going to be at 180. So if I'm doing the cosine of 5 pi, what do I get? You'll think about I'm at 180 on the graph. Plot that point. Well, the x value there is, everybody agree, -1 plus I, and then the sine of pi would just simply be the y value at 180, which is 0. So basically we're doing 4 times -1, which is -4 would be my answer on that one. Any questions with that?